Good evening, everyone. I am Edibeseda Ertem, and I am a lecturer at Aydın Adnan Menderes University at Department of Food Engineering. Today, I will talk about sensor evaluation of gluten-free, non-bread bakery products. I will start with introduction, objectives, and sensor analysis methods, then continue with recent sensor studies on gluten-free, non-bread bakery products, and then conclude my presentation. Gluten is a protein complex which is found up to 80% of protein content in cereals such as wheat and rye. As it's seen in the figure, it consists of gliadin and glutenins which binds each other with hydrogen bonds. There are 4 reasons for gluten-free diet in general. They are celiac disease, gluten allergy, gluten sensitivity, and even though there is not enough scientific evidence to lose weight with a healthy diet. When wheat is replaced in gluten-free products, some problems arise which are quality attributes such as low dough viscosity and texture defects, nutritional characteristics such as low protein and fiber value, and consumer acceptance such as appearance, texture, and taste changes. Wheat flour replacement is done in gluten-free products with 1 to 3 combinations of following methods. First one is using gluten-free flours such as legumes, gluten-free cereals, gluten-free genetically modified wheat, and starches. The second one is adding functional ingredients such as hydrocolloids and fibers. And the last one is using novel processing approaches such as enzymes and lactic acid bacteria. So, the objective of this review was to investigate the recent publications on sensor analysis of gluten-free non-bread bakery products such as cakes, muffins, cookies, and biscuits. Let's take a look at the sensor analysis methods used for gluten-free products. There are 3 types of sensor analysis in general. First one is discrimination test, which is an analytical method and uses trained panelists. The second one is descriptive analysis, which is also an analytical method and uses trained panelists. The last one is consumer acceptance tests, also known as affective test or consumer test. In this kind of analysis, hedonic scales and untrained panelists are used. Next, let's talk about recent sensor studies on gluten-free non-bread bakery products. First, we will take a look at the studies on muffin and cakes with trained and semi-trained panelists. Out of 5 studies, 4 of them used rice flour as a base material and enriched it with various ingredients. Another base material was chickpea flour. There were 5 to 30 trained and semi-trained panelists in these tests. The product with chickpea was liked when xanthan gum added. In case of other products, when citrus fiber, pumpkin flour, cowpea flour, and pecan nuts added to rice flour, panelists liked the product better. Next, we will take a look at the studies on muffin and cakes with untrained panelists. Out of 4 studies, 2 of them used rice flour as a base material and enriched them with quinoa and carob flours. Other base materials was banana and sorghum flours. So 76 to 151 untrained panelists involved in these consumer tests. As you know, quinoa has its unique flavor. When malted quinoa used, consumers liked it better. Adding carob flour enhanced the acceptability of muffins. And green banana flour was highly acceptable replacement for wheat flour, and adding orange pomace and whey protein to sorghum flour gave the best results in a cake. Next, we will take a look at the studies on cookies and biscuits with trained and semi-trained panelists. In the first study, up to 20% addition of palm flour was acceptable to cookies. In the second study, product with 7-20 to 10 foxtail, barnyard, and kodo millet flours had the highest score in cookies. Next, we will take a look at the studies on cookies and biscuits with untrained panelists. Out of 7 studies, 5 of them used rice flour as a base material and enriched them with various ingredients. Other base materials were pinto bean and manioc flours. 31 to 110 untrained panelists involved in consumer tests. Type of pinto bean flour did not affect the results for cookies. And in manioc flour samples, up to 30% of addition of soybean okara was acceptable. In the next 2 studies, increased amounts of peanut okara and potato pulp to rice flour were more acceptable. And in the last 3 studies, maximum 50% of sorghum flour, 25% of inulin, and 25% of potato starch addition to rice flour were acceptable in cookie and biscuit samples. In conclusion, in recent studies, generally rice flour was enriched with other flours and functional ingredients to increase nutritive value of gluten-free non-bakery products. With the increasing celiac awareness and tendency to have gluten-free diet, there is more demand on gluten-free food products in the market. On sensor analysis, trained and untrained panelists had similar outcomes, and further studies should be carried on to increase the variety of these products and to find best suitable ingredients to be used for acceptable quality and consumer acceptance. Here is the first page of references and the second page of references. Thank you for listening to me.
Merhaba. Projemizin konusu farklı ham madde kaynakları ile alternatif çikolata çeşidi. Merhaba. Projemizin konusu farklı ham madde kaynakları ile alternatif çikolata çeşidinin geliştirilmesi, yani ısıya dayanıklı süper kokain elde edilmesi. Proje kapsamında sunumda anlatacağım konular: ısıya dayanıklı kokolin neden önemlidir? Çikolata, kokolin ve süper kokolin arasındaki farklar nelerdir? Proje kapsamında hangi çalışmaları yaptık? Bu projeye başlamamızın sebebi, standart kokolin ürünlerinin istenen yapı özelliklerini sağlayamaması, Çikolata ürünlerinin yüksek maliyetli oluşu, sektörde ısıya dayanıklı süper kokain ihtiyacının olması, daha az maliyetli ve daha yüksek teknoloji ürünleri olan eğilimin artması, sektörde benzer ürünlerin popüler hale gelmesi, son üründe kullanılan bir ham maddeden birden fazla fayda sağlamanın o ürünü değerli kılıyor olması, ayrıca da ısıya dayanıklı ürünlerin artık bir trendten çok seri üretim için ihtiyaç haline gelmesi. Çikolatanın ana ham maddesi herkesin bildiği gibi kakao çekirdeğidir. Çikolata üretim 6 basamaktan oluşmaktadır. Ham maddelerin beslenmesi, karıştırma yani mix aşaması, ikili inceltme, ön inceltmeden geçmesi, sonrasında akabinde beşli seride inceltme yapılması, konçlama ve eğer şekillendirme yapılacaksa da temperleme ve paketleme aşamasıdır. Çikolata ve kokolin arasındaki en büyük fark çikolatanın kakao yağı ile elde edilmesi, kokolinlerin ise bitkisel yağ kullanılarak elde edilmesidir. Süper kokolin ürünü ise CBE yani kakao yağı eşleniği kullanılarak elde edilen kokolin ürünlerdir. Tat ve yapı profili olarak çikolataya çok yakındır. Çikolata ürünlerinin kullanıldığı pazarın giderek genişlemesine bağlı olarak çikolatanın yapısına daha yakın ve kokolinden daha yüksek performans gösteren son ürün çalışması gerçekleştirilmiştir. Literatür araştırmalarında bitkisel yağlar ve bazı polimerlerin eklenmesiyle ısı stabilitesinin arttığı gözlemlenmiştir. Amerika'da yapılan araştırmaya göre özellikle pastacılık sektöründe ısıya dayanıklı ürünlerin kullanımı artan bir trend göstermektedir. Yurt içi ve yurt dışı piyasadan toplanan 10 farklı ürün çalışması doğrultusunda ürün partikül boyutunun 20 mikronun altında olması gerektiği ve yanık tadın istenmediği belirlenmiştir. Bake-stable ürünlerin kullanım alanları dikkate alınarak pişirme sıcaklığı 200 derece ve 20 dakika olarak belirlenmiştir. Ürünü süper kokolin haline getirmek için yapılan ilk değişiklik, ürüne kullanılan kakao yağına alternatif kakao yağı eşdeğerlerinin seçimidir. 4 farklı firmadan yağ numuneleri istenmiş, Çukov cihazıyla soğuma eğrisine bakılmıştır ve yağ numunesine karar verilmiştir. Bu yağ numunesiyle elde edilen son üründe de mikrobiyolojik analiz, renk analizi yapılmış ve duysal değerlendirme sonrasında stabil olan ürün tercih edilmiştir. Farklı yağın Shukov analizine göre Q faktör değeri 0,18 olan yağ 3 tercih edilmiştir. Amacıyla 4 farklı yağla yapılan son ürünler duysal analize alınmış olup örümcek ağ diyagramında da görüldüğü üzere off-taste hissedilmeyen ve asit tadı en az algılanan yağ 3 tercih edilmiştir. Tercih edilen yağ sayesinde süper kokolin haline getirilen ürünlerin ısıya dayanımını artırmak amacıyla farklı ham maddelerin değişen oranlarla denemeleri gerçekleştirilmiştir. Önce reçetedeki dekstrozun oranı belirlenmiştir. Akabinde de diğer ham maddelerde çalışmalar yapılmıştır. Şeker yerine dekstoz anhidroz kullanımına karar verilmiştir. Bu da farklı oranlarda denemeler yapılmıştır. %1, %3, %6 ve %9 olarak. Akabinde ürünler damla kokolin haline getirilmiş ve pişme denemesi yapılmıştır. %1 ve %3 oranındaki reçetelerle yapılan ürünlerde dağılma gözükmüştür. %6 ve %9 oranında kullanılan ürünlerde ise pişirme sonucu uygun bulunmuştur. Maliyetten dolayı %6 kullanım oranı olan ürün tercih edilmiştir. Dekstoz oranı reçetede belirlendikten sonra yapıyı destekleyebilecek alternatif ham maddelerde denemeler yapılmıştır. Bunun için gliserin monesterat %60'lık, %90'lık modifiye nişasta ve un denemesi yapılmıştır. Hepsi %1 oranda kullanılmıştır. Son ürün elde edilmiş ve pişirme deneyi yapılmıştır. Pişirme deneyi sonucunda bütün hepsi uygun bulunmuştur. Daha sonrasında da duysal analize alınmıştır bu ürünler. Duysal analiz sonucuna göre de GMS 60 tercih edilmiştir. Örümcek ağ diyagramında da gözüktüğü üzere BMS 60 ile yapılan ürün tercih edilmiştir. Reçetesi belirlenen ürünün kuru konçlama ve partikül boyutu azaltma aşamasına değişiklik yapılmıştır. Önce proses parametrelerini belirlemek için 9 farklı sıcaklıkta kuru konçlama yapılmıştır. 45-80 derece arasında değişen kuru konçlama sıcaklıkları denemeleri yapılmış olup nem değeri 0,8'in altında olan C6, C7, C8 ve C9 tercih edilmiştir. Bunlar duysal analize alınmış olup %65 oranında C6 koncu tercih edilmiştir. Denemelerde dextroz ve ısı sabit tutularak partikül boyutu değiştirilmiştir. 18 mikronla 40 mikron arasında farklı çalışmalar yapılmıştır. Bunlardan elde edilen ürünler son ürün olarak damla kokolin ürünü elde edilmiş ve pişirme testi yapılmıştır. Hem ısı stabilitesi testinde hem de duysal testlerde başarılı olan 15-20 mikron arası tercih edilmiştir. Projenin sonucuna göre her CBE yağının çikolataya yakın özellikte ürün elde edilimine katkı sağlamadığı görülmüştür. Modifiye nişasta ve unun kokolin üretimlerinde kullanıldığı gözlemlense de yapılan tadım testlerinde başarılı sonuç elde edilmemiştir. Yapılan çalışmalarda dekstrozun ısı stabilitesine etkisi olduğu gözlemlenmiştir. Dekstroz ile birlikte kullanılan YMS'nin stabilitede artı yönde etki sağladığı görülmüştür. Konç sıcaklığının ısı stabiliğini sağlamada etkili olduğu görülmüş olup 70 derecede hem duysal hem de ısıya karşı dirençli ürün elde edilmiştir. 70 derecenin altındaki sıcaklıkların stabiliteye olumlu etkisi olmadığı, üstündeki sıcaklıkların ise duysal analizlerde tercih edilmediği saptanmıştır. Partikül boyutunda 25-30 mikron inceliğindeki ürünlerin ısı stabilliğinin daha iyi olduğu gözlemlenmiştir. Dinlediğiniz için teşekkür ederim.
Good afternoon, everyone. Today, I'm Good afternoon, everyone. Today, I'm talking about performance analysis of ohmic heating assisted pectin extraction process. First one, we are going to see an introduction. What is pectin? Pectin is a polysaccharide group having a complex structure that is naturally found in the cell wall and intercellular region of the non-green plants. Because of the difference in the extraction method of the pectin, the molecular weight varies over a wide range. There are two different pectins. It depends on the degree of esterification. First one is high methoxyl pectin and low methoxyl pectin. And what is the area of the usage of the pectin? Pectin is widely used in the food industry for the gelling, thickening, water retention capacity, and stabilizer. Because of these properties in the food industry, it is widely used in fruit and vegetable juices, jam, pastry jellies, marmalades, candies, fruit creams, and several dairy products. How is the extraction of the pectin? Pectin extraction process is a process of extracting the pectin-rich product by treating it in a solvent ranging from a specific pH is between around 0.7 and 1.5, and temperature is around 60 to 100 degrees centigrade for 1.5 to 3 hours. Now, what's the methods? First one is conventional extraction method. It's a very simple method, but has some disadvantages. Extraction temperature is very high, and it is long, result in the deterioration of the pectin metallic structure, or significant loss of pectin quality properties can occur. Therefore, pectin yield and quality of the product obtained as a result of traditional extraction process are adversely affected. It's kind of negative effect. These advantages of the traditional method have led researchers to use a new alternative current technology and applications. What is the new methods? Ultrasound, high hydrostatic pressure, pulse electrical field, moderate electric field, microwave, and ohmic. Studies with extraction application have increased in recent years. However, this technique, except ohmic heating, some disadvantages such as high initial cost, lack of pectin in the desired yield and quality, difficult temperature control and process controls. In this context, there are very limited studies on pectin extraction with ohmic heating methods, which is one of the new alternative heating. What is the usage of the ohmic heating in the food industry? It is used in many areas, such as heating, blanching, thaiving, evaporation, cooking, distillation, and extraction. What is the aim of this study? Using ohmic heating, we use 3 different solid-liquid ratios and 3 different voltage gradients. And we use grapefruit powder, and what we make, statistical evaluation of pectin production yield and performance analysis. What is our material? It's a grapefruit. It was obtained from the local market. First we wash it and dry it for to remove the water on the skin. And then also we skin the skin was removed. And then we dry it in a rotary dryer and screening and sieving in 500 micron sieve. And what is our system? It includes the isolated transformer, we call it variac, thermocouple, 2 electrodes, 1 test cell, and 1 stirrer, and computer and microprocessor. It is one of the current methods. What is the principle? Passing the electric current through the food, and then electrical heated method provides fast, homogeneous, effective heating, and it changing depends on the conductivity. What's the conditions? Our pH is 1, and what is the solid liquid ratios is 20, 40, and 60 milliliter per gram, and stir rate was 120 rpm. We heated from 20 degree to 80 degree, and we have 3 different time scale: 0, 90, and 180 minutes. In this slide, we are seeing general energy equation as seen in this here. What is the inlet energy in here? Ohmic energy, total ohmic energy, output energy, energy efficiency, and specific production coefficient. This is the exergy analysis, same as inlet exergy. It is the total of the solid part, liquid part, equipment part, and ohmic and the stir. The same in here. Output exergy is out of solid part, liquid part, and equipment. In here, we see the destroyed exergy and energy efficiency. The IP is improvement potential. We will see later. In this slide, we see the total voltage gradient, solid liquid ratio, different several of them, and what's the effect on the total ohmic energy consumed, energy efficiency, and SPCC value, and I explain now. In all applications, it was determined that the value of the total consumed energy increased as the time increased, as expected. When the effect of the ohmic heating process on the energy efficiency values was examined, it was determined that highest energy values were obtained in 0-minute extraction process. However, as the waiting time increased, the energy efficiency of the system tends to decrease. The main reason for this situation can be explained by the negative effect of the mixing process used in the system on the energy efficiency values, in other words, and decrease in it. In the process, it has been determined that the specific Bechdel production coefficient (SPCC) value decreases, especially due to the increased process time and solid-liquid ratio. It was determined that SPPC value increased depending on the increasing voltage gradient. In this slide, we see the exergy values. When the exergy efficiency values obtained from the process were examined, it was determined that highest exergy efficiency value were obtained in 0-minute again. It has been determined that exergy efficiency values tend to decrease depending on the increase in the waiting time applied. In addition, it is seen that exergy efficiency is lower than energy efficiency under all examined process conditions. It has been determined that lowest IP value improvement potential values are obtained in 0-minute waiting time of the process and are in all parallel with the exergy efficiency. It was determined that IP value increased due to the increase in the waiting period. As a result, it has been determined that especially the 180 minutes in the process need improvement or should improve. As a result, there is a negative impact of processing time on total consumed energy. While the highest energy efficiency was achieved at the lowest processing time, it decreased with increasing processing time. Specific Bechdel production coefficient decreased with increasing TCE value. It has been determined that the processing time has a negative effect on exergy destroyed and decreases with increasing processing time. Exergy efficiency results in parallel with energy efficiency, and exergy efficiency decreases with increasing processing time. On the other hand, the IP value has decreased due to the increase in the processing time. And this project has been supported by TÜBİTAK, and project node is 2180135. Thank you for your attention.
Good evening, ladies and gentlemen. My name is Tayyip Erten. Today I'm going to talk about polysaccharides and their roles in food formulas. Good evening, ladies and gentlemen. My name is Tayyip Erten. Today I'm going to talk about polysaccharides and their roles in food formulas for satiety. Before starting presentation, I would like to mention about outline of the presentation for today. Firstly, I'll start with introduction part. After that, I'll move on to satiety and food relationship. Then I will talk about polysaccharides and satiety mechanisms, how they affect on satiety, which way they affect, something like that. After that, I will talk about polysaccharides that used for food formulas. Although there are a lot of polysaccharides can be used for food formulations, today I'll talk about just 3 of them, which are pectin, alginate, and beta-glucan. Since the time is limited, so I will just talk about 3 of them. After that, I will talk about conclusion and then I will finish my presentation for today. As we all know, obesity prevalence has been increasing every year beyond with the predicted ratio. Especially childhood and adolescence obesity is increasing every year. This situation is not only threatening obesogenic environment also plays an important role in this case, since it encourages to eat more high energy intake foods by stimulating the appetite. Therefore, alteration of the food formulas has become necessary by reducing the energy, salt, sugar, and fat proportions in the food. Satiation and satiety are inhibitory process of food intake. Although it can be affected by various physiological and psychological factors, food structure is also one of these factors. Enhancing the satiety of the food is one of the proposed actions to decrease the food intake. And it also leads with healthy eating and weight management strategies by lessening the effect of sensation of hunger on motivation and mood. To increase the satiety, usage of food proteins and polysaccharides were recommended and their effects on satiety were examined in recent years. Since satiety effects of semi-liquid foods are higher than liquid foods, soluble polysaccharides can be examined for designing food with this purpose owing to their gelation properties and viscosity. Furthermore, some possible mechanisms were introduced to explain their satiety effect, which are, firstly, solutions of viscous polysaccharides impart high viscosity, which may increase exposure time in the oral cavity and induce sensory-specific satiety. Second, viscosity polysaccharides may form gels of certain strength in the stomach, for example, gastric gelation, and have high water holding capacity, thereby increase stomach distension, which may trigger signals of fullness via the afferent vagus nerve system. Thirdly, viscosity polysaccharides may delay gastric emptying, therefore prolonging the absorption of the nutrients and extending the time available to stimulate pre- and post-absorptive mechanisms of satiety. Lastly, the increased viscosity of digesta in the small intestine can lead to prolonged presence of nutrients, which in turn stimulates the release of appetite-regulating hormones, for example CCK, GLP-1, PYY. About this topic, research on polysaccharides and satiety effect were concentrated on soluble food fibers. Fiber is a complex and varied macronutrient encompassing a range of non-starch polysaccharides. Fiber is also thought to affect satiety in many ways, depending on the fiber type, relating to its ability bulk foods, increase viscosity, gel in the stomach, and ferment in the gut. Soluble fibers is also known as soluble polysaccharides. In this study, we will just concentrate on 3 of them: pectin, alginate, and beta-glucan. Pectin is high molecular weight heteropolysaccharides containing acid units, and the range of neutral sugars, including rhamnose, galactose, and arabinose. According to their methoxyl content, their gelation capability may change. Therefore, satiety ability of pectin were extensively researched. Here we will just talk about three of them. Firstly, Seneca and his co-workers examined the 2-gram agar and 5.2-gram pectin in ready-made nutritive drink. And the authors reported that 5.2-gram pectin in the drink delayed gastric emptying but had no effect on postprandial glucose response when compared with the control. Another one, Perry and his co-workers also performed a study to investigate the satiety effects of 8-gram pectin addition in a low-calorie beverage. As a result, they found beverages with added fiber, reduced energy intakes, and short time interval between consumption of a low-calorie beverage and the meal also increased satiety and decreased the food intake. Lastly, Wonders and his co-workers investigated dairy-based liquid test products containing bulking pectin, viscous pectin, and gelled pectin. They found that appetite was reduced after ingestion of gelled pectin compared to bulking and viscous pectin. Also, gastric emptying rate was delayed after gelled pectin compared to control. Furthermore, gelled and viscous pectin lowered insulin responses compared to control, with minor reductions in glucose response. Second one is alginate. Commercial production of alginates utilizes marine brown seaweeds. Owing to its high water holding capacity, gelling capability, and emulsification properties, alginate is used in many food and food products. To investigate the satiety effect of alginate, Solah and his co-workers compared calcium-rich breakfast drinks with either whey protein, low viscosity alginate, or high viscosity alginate. With significant hunger reductions, they concluded that the high viscosity alginate drink reduced hunger more than the low viscosity alginate and the whey protein drinks. Having observed with the high viscosity alginate drink changed from a thick liquid after 5 minutes to a gel formed at 30 minutes, they suggest that the likelihood of thickening or gelation in the stomach, which may have contributed to the high satiety effect observed. Jensen and his co-workers also compared alginate in beverages of low volume and high volume. Increased satiety, reduced hunger, reduced prospective food consumptions, and lower gastric emptying rate were shown with the high viscosity alginate beverage. Lastly, let's move on to beta-glucan. As a viscose fiber and soluble polysaccharides, beta-glucan from oat bran were highly examined in food formulas and extensively studied. But since the time is limited, I will mention just the two of the examples. Firstly, Yunan and her co-workers investigated the effect of oat fiber viscosity on postprandial satiety, related GI hormone responses, and satiety in healthy young men and women. In this study, the participants consumed beta-glucan added beverages having high viscosity and low viscosity. As a result, they found that the high viscosity beverage slowed gastric emptying and reduced satiety hormone responses compared to the lower viscosity beverage, leading to lower total energy intake over the course of the day. Another study was performed by Pentkinen and his co-workers. They examined wheat biscuits and orange juice, and these products were either enriched with oat bran concentrate or not enriched for control. They reported that the addition of oat bran to biscuits and orange juice increased postprandial satiety. To conclude, I would like to say that soluble polysaccharides, especially pectin, alginate, and beta-glucan, have indicated that they can be used for food products, aiming with appetite control. Although other polysaccharides like guar gum, carrageenan, or polysaccharide blends, xanthan alginate conjugate glucamannan, or alginate and xanthan blends, etc., were examined, further research on other gelling polysaccharides might be useful to investigate for weight management to decrease the obesity rate in the world. Thank you for listening.